In the last episode, we brought the full stack online with Docker, Flask, InfluxDB, and Nginx, all running on the industrial computer. But so far, it has been monitoring nothing. Today that changes. We connect our first real device, an industrial compressor station, and we do it over OPC UA, the universal protocol of modern automation. By the end of this video, live data from the compressor's PLC will be flowing into our hub. Why OPC UA? In a traditional setup, every device speaks its own dialect, Modbus, a proprietary PLC protocol, a vendor SDK. OPC UA, standardized as IEC 62541, is the common language. The PLC exposes its data as named nodes on a server, and any client can read them, regardless of the manufacturer. Our compressor runs a B&R controller, but our hub doesn't need to know that. It just connects to the endpoint, asks for a node by its address, and reads the value. And it does so securely. OPC UA has industrial-grade encryption built in. Our compressor's PLC is configured to require a secure channel, basic 256 SHA-256, which signs and encrypts every message. So the connection isn't just open and standardized, it's also confidential and tamper-proof, exactly as IEC 62443 expects for industrial cybersecurity. We start in the admin interface, devices, new device. The device is the connection to a physical unit, here the compressor's OPC UA server. Driver, OPC UA Client. Notice the form adapts. It now asks for an endpoint URL instead of an IP and port. We point it at the compressor's OPC UA server. Then the important field, OPC UA Security. We set it to basic 256 SHA-256, sign and encrypt, so our hub identifies itself with a certificate and the entire channel is encrypted. The certificate is the same one our own OPC UA server already uses. We simply reuse it for the client side. Scan interval, 2 seconds. The compressor's state doesn't change millisecond to millisecond, so 2 seconds is plenty and keeps the network light. Save. The device is registered and it will connect over an encrypted channel. But a device on its own reads nothing. We have to tell it which value we care about. That's a tag. Tags, new tag. A tag is a single value we read from the device. The compressor publishes its operating state as an integer. 0 is off, 4 is load run, 7 is fault, and so on. We'll map those numbers to human-readable text. The key field is the OPC UA node ID. This is the exact address of the value inside the PLC. I found it using UA Expert, a free OPC UA browser. You connect to the server, expand the address space, and copy the node identifier. Paste it here. Tag type reg, a register holding an integer. And here's the nice part, state labels. Instead of showing the operator a cryptic number 4, we map each integer to text. 0 equals off, 4 equals load run, 7 equals fault, 1 value per line. Now the dashboard will speak in words, not codes. Saved. The tag exists in the database, but it isn't being read yet. And that's a deliberate important detail. Here's that important detail. Our polling engine loads its list of devices and tags once at startup for efficiency. So a tag we add while the app is running isn't being polled yet. In an earlier version, we'd have restarted the whole container, but we built a cleaner way. Right here on the tags page, reload configuration. One click rereads the devices and tags into the running poller. No restart, no downtime, no other tag missing a beat. Done. The banner confirms it. Configuration reloaded, polling our device. The new tag is now live in the polling loop. Now the moment of truth. Back to the admin tags list. There it is. The quality indicator for compressor state just turned green. Good. That single green dot means our hub successfully connected to a real industrial PLC over OPC UA, asked for the node, and got a valid value back. The compressor is now being monitored, live, every 2 seconds. First real device, connected. No code written today. The OPC UA driver was already built. We just configured it. The data is flowing, but right now it lives in a database row and a green dot. In the next episode, we make it visual. We'll build a dedicated dashboard page for the compressor station with a live faceplate that shows the operating state in plain words and updates in real time on screen. That's where it all comes together. See you in the next one.